Okay. Now, last week we stopped at this design process. So again, this diagram is important. Okay. So chapter 7, we go into second half of the chapter. We now first part is more on the process design or process planning. And another part in your module, you need to know about this is also another analysis, process analysis and planning. So we're already done with the process planning. Now we go into analysis. So this is a video for chocolate manufacturer.
Hi, I'm Mark
So
Summers.
they
Welcome
have
to
some
Unwrapped.
methodologies
Candy,
in
it is
their
a staple in
chocolate
American pop
products.
culture. Over, ready for this, $14 billion worth is purchased each year, and undoubtedly, candy bars make up a huge bite of that profit. And a preference for candy bars really isn't something new. Their history goes back more than a century, and a major part of that history is the name that definitely put some sweet into the American tooth. It's got to be Hershey.
Shake, rattle, and roll. Welcome to the Hershey factory in Hershey, Pennsylvania, birthplace to billions of bars.
At the Hershey plant here in Hershey, Pennsylvania, we produce well over 1.5 billion pounds of chocolate.
The candy bar, the factory, the town, all are named for Milton Hershey, chocolatier extraordinaire.
So this brand,
Hershey was
familiar,
born near,
right?
well, Hershey, Pennsylvania
So famous,
in 1857 and went into the candy business at age 18. But the sweet taste of success didn't come easy.
In 1876, for the centennial, he went to Philadelphia, started his own company. That company failed. He went on to build and start 3 more companies, all of which failed.
Hershey's confection companies finally stopped failing around 1900 when he started to make a popular line of chocolate syrups and candies. And his premier product was the simple but scrumptious Hershey bar. Today, Milton's namesake is still almost the exact recipe he came up with in the late 1890s. A mix of cocoa beans, sugar, and milk. But don't be fooled, making it is still a major production.
So while it seems like a very simple product and anyone can make chocolate, it's really very hard, very challenging. There's a lot of science and technology in there.
Here in Chocolate Land, science and technology means enough gizmos, gadgets, and gadgets to make Willy Wonka weep. Big blades first mix the dry blend of cocoa and sugar called crumb. Then huge mixers called conches roll up and stir the chocolate for up to 3 days. Then the chocolate paste is squirted into molds, passed through tunnels, cooled down, and wrapped up.
So from the time we receive the bean till it's wrapped, put in its wrapper, and on its way out the door.
So one thing is that you notice that for
So what's the secret to getting the bar shaped just right?
We shake that bar to evenly distribute it in the mold. So when it's cooled, it comes out as a square bar.
And there's a reason why.
But it's during this dangerous trip down Shakedown Street that many good bars go bad. Unfilled corners, air bubbles, broken edges, all will disqualify a bar from making it to the wrappers and cause them to be picked off by the eagle-eyed inspectors.
And the Hershey bar has to be perfect when you look at it. We like a perfect look, perfect feel.
So why do Hershey bars come in that flat rectangle shape?
More easier to melt compared to the one.
I've never been asked that question in 15 years. Okay.
So that is
okay, so there may not be an answer to how this candy began as a bar, but whatever the reason, the recognizable rectangle is here to stay.
A rectangle is a shape everybody's comfortable with. It's easy to make, it's easy to mold and manufacture.
The shape may be simple, but there is a mystery that surrounds this chocolate bar. That well-known, oh so familiar wrapper, what color is it?
Brown.
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 Brown and white and silver.
Close, but not.
Okay, the rest you watch lah. Okay, so again, what is a few definition there? I will go very fast. Right, process is related to input and output. Like a task that you have input and output. And process design is you define what to do and how they do. Okay, process is more on task. But if you add the process design, the design part, it means you have to give definition to that specific task, right? And then if you change the word design into strategy, process strategy is the approach, the overall approach. Okay. So the process strategies for the firm, you have 1, 2, 3, 4. You have vertical integration, right? So you in previous chapter, you learn about organization chart. You learn about WBS. So you have level 1, level 2, level 3, level 4, level 5, level 6. So this is the first one is vertical integration. You have capital intensity, process flexibility, and customer involvement. So these are the technical words that usually when it comes to process planning. Okay. So process planning is you convert the design into instruction. You convert the design into instruction. And here you have outsourcing decision, process selection, and process plan. You have three main component that you need to handle when it comes to process planning. Okay. Now, just now we learned what is vertical integrate. Right? So this is a vertical integrate process where you can see that it's work from the main source, for example, the cattle, and then you slaughter them, and then you cold them, you store them, then you deliver it to the warehouse. So this is a vertical integration. So you sell the products assembly, then makes a part, and then you extract the raw material completely. This one is called vertical integration in the process. Okay, so this is more on the raw material. Second one, horizontal integration. As you can see, it's a bit different. So horizontal integration means you have process 1, process 2, process 3, process 4, then you fit inside the main silo or main process. Okay, so you have vertical and you have horizontal integration. Huh? So that, yeah, that one consider horizontal. Okay, vertical one is like from one source. The main output is that you get the ingredient or the raw material. Okay, so that one. So for example, the coal, you do mining, and then you store. That one is vertical. Okay. Okay. So these are the questions normally we come to plannings, right? Okay, so when you outsource decision, you need to consider a few factors. I'll give you all. All right. Oops. So the first one is cost. Of course, when you deal with business, you talk about cost first. So when you outsource them, you need to consider cost. Then another one is your capacity of your factory or your manufacturing process, right? Whether you can make or you cannot make. So if you have company, you have two scenarios. So if your company that operate less than the full capacity, then you can make component rather than by that means if you can produce, if your machine can produce 10 pieces of parts, but your customer needs, your customer only buy like 8 parts from you. So you can actually handle the customer requirement. So what you do when you have a low than your full capacity, you make the component yourself. Okay, but if the available capacity is not sufficient, then you can either two cases, you can produce more customized products, or you can outsource them at a high volume of standardization. Okay. Okay, quality, you know lah. Okay, this one you read. Speed, this one is more on shipment. So when you in business, shipment or delivery to the customers is important. So most of the time, customer doesn't care what is happening between the process. They only see one whether you deliver on time or not. So cost, capacity, quality, and speed. These are the factors that you consider when you outsource them. Huh? Okay. Reliability, previous class, you learn about what is reliability. You calculate the reliability, you calculate the system availability last week, right? So when you talk about reliability, if you see the company using ISO 9000, means it's having a quality check system, quality system, your expertise, and so on. Okay. Okay, so this is also another important chart table. So production process, you can split them into a few categories or classification. So first is project-based batch production, mass production, and continuous production. So if you draw a chart, on the left is your volume, low to high. Your x-axis is from low standardization to high standardization, right? Now, volume, you know how many pieces you sell or deliver. Standardization means you have a more standard procedure, fix that, or at this station you do what, that station you do what, right? Or there's a checklist to do, like, okay. So if you're under projects, means your standardization is considered low and volume is low, then you go for projects. Okay. But when your volume is a little bit higher, then you increase your standardization, then you become a batch production already. Then you keep increasing. If your volume increase and in the production floor is more machine, more standardization, then it become mass production category, and so on. So as you increase higher and higher volume and higher standardization, the highest one is continuous production. Yeah, so this is quite direct. This is called product process metrics. So if the question asks you to draft or explain the production process classification using a diagram with volume, maybe I don't tell you volume, but I tell you by using product process metrics, means it's asked you to draw this one. Okay, quite easy lah. Okay, the rest you read. Yeah, project will be like doing ship, right? You construct a ships, you do one unit by one time, right? Although there's some standardization, but the volume is low. Okay. Batch production is like making rotis, making breads and all this, the bread production. Mass production is like the top left, doing all this. We have mass production. Again, I highlight all the main point there. You just go and read the slides. So for mass production, the product demand is stable and the volume is high. Continuous, this one is like the petrochemical company or project, not project, but the petrol company things, they cannot stop one. Once they drill, they have to continue until the well is dry, for example. Okay, this is a continuous production. So it's highly automated and continuous 24 hours. Okay, so these are all the selection, is a summary of the 4 categories: project, batch, mass, and continuous production. So there is a type of project, type of products, customer, demand, volume, production system, worker skill, advantages, disadvantages, and example. Okay. So you have seen what task 1 look like. So later I will brief you if this kind of question come out lah. So if this process planning question come out, then this is a table will help you to answer. Beside drawing the graph just now, the matrix just now, then another one is on the using this table to explain what is the differences between, for example, maybe the question asks you explain the differences between project and continuous production. So you use this table to help you to answer. Okay, next there's some calculation, right? So in engineering program, most of the time we assess you, we like to ask you question with equation, right? So last class we learned a few equation. So this is also a few equation, but should be easy for you guys. So first we will do for project selection. We will use a process called break-even analysis. So if you're in the business, then you have to know the break-even means the cost and the profit is you do not loss, you do not you make profit or you maintain equal. Okay. So like you do the projection for present value and future value, it's the same, but this one is more on a process. So process, you deal with the volume, quantity, and so on. So what does it mean by break-even analysis? So you do cost trade-off associated with demand volume, means you deal with cost and volume. Okay. In process selection, you always look at the cost and the volume. Okay, so in the break-even analysis, we look at 4 parameters: volume, cost, revenue, and profit. Okay. So for volume, there's a definition there, right? It's a number of units you produce. So you can from, for example, item, right? So when you work in the business later on, the unit of volume is important because in the contract, in your quotation to your customers, you need to mention clearly what is the unit that you quote, right? So if you mention per item, then means 1. But if inner pack means something like this, one case is like this, one pallet is like this. Pallet means you have a wooden pallet here. It's for shipping, for either by air or by sea, or maybe by land. Okay, so be careful on the unit. Okay. Cost, you have 2. One is fixed cost, one is a variable cost. We have 2. So later in the break-even analysis later, you need to identify which one is fixed cost, which one is variable cost. Okay. So fixed cost is, for example, number of unit that you produce or equipment you need to buy that is fixed already. Other one, like for example, variable cost, for example, your labor and material cost. That one is like per kilo or per hour, how many money you charge. So that one you can change one, right? But fixed cost is mean fixed already, like one machine, how much? One machine, how much? Okay. So total cost, you combine fixed cost and variable cost. This one is quite easy lah. So two later when you do break-even analysis, you look at what is fixed cost, what is variable cost, then you combine them, become total cost. Then you compare process A, process B. Okay, nothing complex here. So the equation for today, first one, total cost equal to fixed cost C sub F, right? Plus volume multiplied by variable cost. Okay, V is volume because variable is per unit. It's per unit. So you have to multiply like how many unit you use for the variable cost. So, but the main idea is total cost equal to the fixed cost plus variable cost. But the total variable cost you have to multiply by the numbers that you need to use. Okay. That is the first equation for today for break-even analysis. Break-even analysis. Okay. Now, another one is revenue. Revenue is per unit basis. So it's price with an item is sold. So revenue is how much you sell them. It's called revenue. Okay. So total revenue is how many volume, how many cars you sell, multiplied by 1 unit of car, how much. So total revenue is use this equation. Second simple equation for today. So just now is total cost. Then second equation is total revenue. Total revenue. Okay. Profit, you know lah. Profit, you take revenue minus cost. Okay, you take how much you sell, the total money come into your account minus how many money that you spend. Okay, so profit is, of course, this ABCD, this one you can use your own one, but when you answer question, you have to explain clearly what mean by the symbol that you use lah. Okay, so you can say profit equal what minus what. Okay, so this is just a elaboration of the previous equation. So you just put in and put inside there. Okay, so because some student you like to memorize the equation. So the previous two, then you combine with the profit, then you can summarize or not. You can rearrange the equation. You become one equation. Okay, but you only need to remember the two. Then you do the third one. No, your test you won't see any formula, but you'll see the standard chart or the value for that one. Okay. Okay. So this one. Normally question with equation given, it will be more harder. You ask you to explain, you ask you to do a lot of complex things because we already give you the formula. So it will ask you to maybe elaborate on the equation, and then it will be more harder. Okay. All right. Now to break even, we must equal our total revenue equal to our total cost. Makes sense, right? Your take-in money must equal to the total money that you spend. It must be same. So to break even, TR must equal total revenue must equal to total cost. So you put in the equation. You have a VP equal to CF plus V CV. Okay. So if you plot graph, you know that you have a few type of graph, right? You have linear graph, you have quadratic graph, you have polynomial graph, right? So this module you only deal with I think most is two, quadratic and also linear. So linear graph. So you know that you can plot volume. Later you'll plot, but this is y and x. So if this one is y equal to something, right? So let's say this is a, so y equal to a. Then this is, let's say this is b, this is x equal b, right? So, and then another one, linear graph. Linear graph, y equal to mx plus c. So you have to know how to find m lah. Okay, m equal to y, change of y divided by change of x. Okay, or y2 minus y1, x2 minus x1. Okay, now if you see this equation, the equation on the thing, can you imagine what kind of line that you should plot, right? So one side is one fixed number. So one fixed number equal to, it depends on the axis on the graph. Later I will show you, but you can see this one is a linear equation. Y equal to mx plus c, mx plus c. You can see, so you try to apply what you learn in your mathematics and then apply there. Okay, so again, because you have the same thing, you can move them together, rearrange them, and then you get a V for that particular cases. So to break even means in break even analysis later, you need to find the volume that you will break even. So this is the equation that you will use. You can memorize this one, or you can derive from this equation, the three equation. First is a total cost equation, total revenue equation. Then you equal these two equations. You rearrange, you get the volume. Okay, rearrange, you get the volume. then either you can memorize this one or you can derive in your answer. Okay, now equation won't be given. Okay. Okay, so let's look at how we apply what we learned. So there's two buddies. They want to develop a new products, right? So these two guys, they like to do surfing. So what they want to make a stand-up paddle. Stand-up paddle. They have a platform, a box, then you paddle by the sea, right? So they want to set up. They want to design, marketing the product. The product is paddle boards, right? So what they do is that this is a picture, like if you don't know what is paddleboard, right? Okay, so it looks something like that. So they want to sell this kind of products. Then they continue the case. So with a new fitness craze, the stand-up paddles have gained a lot of very familiar to surfboard. Paddleboard is paddleboard, but surfboard is another kind. But used by individual and navigate down the river in the upright, you need to stand instead of sitting inside the tubes, inside this one. So there's things. So they tell you blah 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 what is the material used for that products. Okay, so they tell you some numbers already. So unlike surfboard for the market, surfboard they sell 500 to 1,000. Paddleboards typically they sell between 100 to 400. So you have a new set of number for you to do analysis. Okay, so there are two buddies. There are two buddies. So they just start up these products, and in the East Coast and not firmly established, they anticipate selling the products for 100 each. So now they plan to sell at $100 per piece per surfboard. Okay, not surfboard, but per paddle boards. Per paddle boards. Estimates. So they have 2%. Now they have 2% here. One is Traverse. Traverse estimate fixed price. Fixed price. Fixed costs for equipment and space is 2,000. Material and labor, this one is per unit, so you know that this is variable. So variable cost is 50 per unit. What volume of demand will be necessary for Traverse and Jeff to break even on their new ventures? So this equation, this question, it asks you to find the break-even equation. It asks you the volume of demand. So if you can memorize, you use the previous equation that you memorized, or your you use the this one. Okay, so total revenue, TR, equal to total cost. Then you derive. At the end, you use V equal to CF P minus CV. Again, what is P? How you get total revenue? You take the volume, multiply by the product that you sell, right? TP. Then CF is a fixed cost, CV is a variable cost. So you have CF, CV, and you want to sell here. So this is your P. Okay, so you substitute inside this equation, right? You'll get the volume. Okay, makes sense, huh? So at least at this stage, you know how to apply, or you know what equation that you should use. Okay, or how you derive the equation from the setting. So what is the answer if you calculate? What is the answer if you press calculator? What's the volume? How many paddles that they should sell to break even? If you substitute value there. Fixed cost is 2,000. They are 40, 40, 40 piece of saddle bag. So let's see the calculation later. So now the solution is like what you see on the screen here. So you substitute, you'll get 40 units. Okay, so you cannot sell below 40 piece at this statement. So second scenario, okay, okay. So how to derive this graph? You establish the price of the dollar at y-axis and unit as your x-axis. This is your cost. This is volume. Okay, so cost versus volume, and then you plot the graph. So how you find total revenue? Total revenue, you take volume multiplied by price of each unit. Right? So this is a linear graph also. Y equal to mx plus c. In this case, your c is 0. This is your m. This is your p or your x. Make sense, huh? So that's why your your TR, total revenue, is this purple line. Yeah, TP equation equal to V multiplied by P. Volume multiplied by each unit of price. So you can see the volume is going up there. Okay, now if in the test you don't make sure you know how to plot the graph for the blue color one. So for example, 1 unit is 100, right? So the first point, of course, 0. What is the second point? Because here you fix your y-axis 1,000, 2,000, 3,000, 4,000. So what is 1,000 point here? It is about 10, right? 10 for the purple color line. 10, then this one 20, and so on. So then you draw a line there. Then here you write TP equal to VP, or you can multiply numbers. V is numbers, unit. VP, P here is 100. So the equation for this line is 100 TRI, TR equal to V multiplied by 100. It's 100 V graph. Okay. Okay, now how to plot the red color line? Okay, red color line, total cost equal this one. Equation, total cost equal to fixed cost plus volume multiplied by variable cost. So the equation for the variable line, which in this case is the one that in the red color. How do you plot the line? So TC line equal to fixed cost is 2,000 plus V you don't know. You just put V. CV is 50. So it's Y equal to MX plus C equation. Okay, so you have two equations that you need to put on your graph. Yeah, you calculate only, but how you know the 40 is to break even. But what if the question change later? Okay. What if the question asks you, what is the differences when they only manage to sell 20? You directly from your graph, this is the differences of the losses or revenue. Which region you have to know how to read. So area under this graph or the line, here is the money that you take inside your bank account, because this is what you sell. This is the one that you need to spend. So anything that below this line is not good, because this is the cost that you already spent. Okay, and this is the money that you sell, put inside your pocket. So any value that below this red line is not good. So any money that above this line is good. So this region is profit region. This is the loss region. Make sense, huh? So this is the point that you calculate just now, 40, break-even point. Okay. Right. Now, of course, you say, sir, can I just memorize this equation to calculate? Not can. Can. The question normally, it depends on the complexity. Sometimes it asks you to plot the graph to prove the answer is 40. Okay. The equation for the red line is what? Total cost. Right? Total cost equal to fixed cost plus V plus variable cost. Correct? So TC equal to, what is your fixed cost in this case? 2,000. What is a V? You don't know. It's a parameter. Which is the variable cost? It tells you 50. So you get this equation. So how do you plot this graph? You start with unit. So when your unit is 0, you get 2,000. Yes. So this one, you substitute 10, you get one number. 20, you get one number. 3, get now one number. So here 40, you get this graph. So until, if on the graph, when you plot these two lines, there's an intersection point, then that intersection point is your break-even point. Okay. Right. So, so these are the equations that we use for the two line. The red color is the slope, the M. The M for the TP, the red color, it has a slope equal to per unit variable cost is your variable cost, CV. Okay, the rest I already explained on the whiteboard. Okay, so this is a travels plan. This is the travels plan. Now, the next one is, you know that when you have two shareholders, so another friend, Jeff, this is another scenario already. So Jeff is more optimistic than Travers, where he believed that demand for paddleboards will exceed the break-even point of 40. So he believed that they can sell more than 40 units. Right? So he proposed spending of 10,000 fixed costs. Now he proposed that to put 10,000 fixed costs. Just now, the fixed cost for Trevor's proposal is 2,000. Now they increased to 10,000. To buy automation products or equipment so that they can able to produce the products faster. Okay, so here you're able to reduce the material cost. Now it's Trevor's, Jeff. Jeff, fixed cost now is 10,000. Variable cost now is reduced already. Variable cost now is 30 per unit. And now the bots is sell for 100, same. Same, selling cost is sell at 100 per piece, regardless which manufacturing process is chosen. Compare the two processes and determine at what level of demand each process will be preferred. Label Trevor's proposal as process A, Jeff proposal as B. So you already done A already. Just now on the graph, you already done A. Now you want to do on the same graph, you do B. Okay. So the first one you already do. So if you do the same procedure, right? What do you think the graph will look like? For the red color line, it will be on the top here. I'll give you so, and there's a condition there, means the demand is more than the break-even point, 40 units. Right? This one makes sense, okay, correct. So you have two set of data there. One is for Travis, one is for Jeff. Yeah. Okay. So if you do the analysis, so you need to find the volume that at the neutral ground. Okay, neutral ground means both cases they will have the same numbers. So on the left hand side, you take the 2000, you calculate the total cost for both process. All right. So for Traverse, you already know 2000 per 50V. So what is the equation for Jeff? Jeff will be 10,000 plus 30V, correct? Now we want to equal the total cost of these two guys. Total cost of A, total cost of B. And then you want to decide what is the neutral ground for these two plans, and then we can do the analysis further. So first you compare the two total costs first. Okay, then what is the V? If you do rearrangement of equation, you get one numbers of V because only one unknown there. All right. So you'll get 400 units. So you need to get this 400 unit to make comparison. Okay, now you get 400 as a neutral ground. So now you get a neutral ground of 400 units. Then only you can argue which one is better, which one is not. Because these 400 units, each total cost is same. Then only you can decide which one is better. Either Jeff is better or Travis is better. Okay. So if the demand is less than 400, then process A will be chosen. Okay, this is a neutral ground 400. Why you say less than 400, you choose A? Because A have lower total cost. If it's 400, I mean less than 400. Okay. Which one? Yes. 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 Yeah. Yeah. It's a decision point.
So now, know that V40 so
yeah, V40 is for Traverse ideas. Second idea is that you have a business partner say, oh, I have this idea. Then how you convince this partner that, okay, we have a decision point. In what scenario you listen to me? In what scenario I listen to you? Okay. Now, first you understand the value of 400 unit here, right? How you get 400? You equal the total cost between the two guys. Traverse total cost equal to Jeff ideas. This one, 2000 plus 550V equal to 10,000 plus 30V. The two guys total cost is the same when you sell 400 units. So at what condition you should listen to which should do this. So this one you must be clearly stated before you run the project. If not, then a lot of problems. Understand? Okay, so that's why we need to find the neutral ground. The neutral ground is 400. So if the unit is below 400, you choose A. Why? because the total cost will be less compared to Jeff. Why? You look at the starting point already, you already know already. Starting point already 10K already. Let's say you sell 10 units only. So of course you choose B, choose process A lah. Of course you choose Trevor's idea. If more than 400, then of course process B you choose process B. The total cost will be less because you run automation already. Yeah, maybe you put 400 or 500 lah. You will see this one will be less, total cost will be less, and this one will be more. You just test the value, you know, right? Okay. So if more than 400, you choose B lah, because the total cost will become less and less because of automation. You look at the total cost, means the capital that you need to pump into the products. Make sense, huh? Okay. You find that one is later. It's just that now you need to have one decision point. At what point you listen to who idea or which proposal is better. Okay. So you can use Excel for you to plot, right? So the blue line, you know lah. Which one? Which idea? Blue line? Trevor's idea. 2000 V50 is very like this. Then this one is Jeff ideas. You have 10K plus 30V. You have this line, orange line. Okay, so when you plot this graph, you will see two segments. And here is, you can say as a break even, but don't use a break even. Break even only apply for total cost equal to total revenue. This graph is to find the neutral ground between the two proposals. Don't confuse between the previous one. Huh? This is to justify which idea is good. Okay. Okay. So if your units is below 40, you know that this is the total cost. So the total cost below 40 is less than the orange color one. This point is a total cost. So only past 400, then you choose B, because B is less total cost. You always choose the lowest total cost. You don't want to pump in more and more money. Okay, nah? Okay. Okay, so for a few more slides. This one is all the. Okay, so this is the process plan, and there is a product called Visual. Previously, it was free, but now the Microsoft already pulled back the free convenient. So you need to purchase now if you want to use Visual to draw the process chart there. Okay, yeah. So for your FYP, if you want to draw all this process chart, you can use Microsoft Visual, but it's a paid version. Okay. Okay. So all this you read lah. Another one is assembly chart. Like for example, you want to assembly burgers. So you have a few layer of assembly. So first layer, then you continue with second layer, and then you complete the Big Mac. So there's a process there. So first process, you combine all these ingredients, become first layer. You combine all these ingredients, you become first layer, second layer. You combine first layer, second layer, you get complete Big Mac. So this is a process flow for McDonald's or KFC. So there's a certain station that need to make. Okay. This is the for plastic sheet. So they have a few process there, right? A few process, and this is an injection molding. Normally, plastic part they use injection molding, right? So this is just 2 minutes. We watch this video. This a China company. Again, they should use PPE and all the occupation health safety procedure is there, because you don't see the operator wearing glasses or any glove. Because why this is a very high pressure or very fast equipment. So if you don't wear all these PPE, quite dangerous. Okay. So what they do is put in the mold inside there, and then they will pump in the liquid, and then they will make pressure. So this is the products that they mix. Okay, they close the thing, then they inject the liquid, then they pull out. Okay, so this is how they do the things. Okay, so I think after we have a short break, we go into process flowchart. How do we do for process flowchart? Okay, we have maybe 10 minutes break. We continue 9:05. Okay, 9:05. We continue. Your assignment is available on Canvas. Those coming late one. Your assignment.